So, hello everyone. Thank you for taking the time in this busy weekday to, be part of this meetup. And I truly hope we can keep this as a continuous learning and sharing opportunity. Yeah. All right. So we'll start out just a brief introduction about Omio, right? We are a multimodal travel ticket booking platform, right? We used to be a search engine where you can just compare offers, but now we issue the tickets. We are a complete ticket booking engine, and we cover the entire life cycle of your travel, right? Yeah, we have over 130 providers, 2,200 carriers like companies, all kind of integrations that you can think about, right? Like HTTP, REST, SOAP, binary protocols, EJBs, file transfers, scrapings, sometimes everything that you can think of. And most of, so we have around 30 million monthly visitors, around 50 million internal platform requests a day. And the main thing is we have a huge amount of rolling inventory, right? It's like when you're looking for like tickets for tomorrow, right? That lives for a certain period. And then after 30 days, after the train departs, it's an entirely new, it's a completely different data. So whatever we are having, it's not like data which stays forever, except the bookings. It's all continuously rolling stuff. The cache alone, right? If you have a train that goes, 10 cities, right? You have like, 10 C, 10 permutations, right? It's like you can go from A to B, A to C, A to D, A to E, B to C, B to D, like all these, the prices are different for each, the availability is different for each, the cache is different for each. If you have one passenger, the prices are different, the availability is different. If you're traveling as a family, for example, Deutsche Bahn will not give you 3 tickets if they cannot put all 3 of you in the same coach, right? So you may have 3 single tickets, but you may not have 1 3 ticket, right? The cache is different. So it's a lot of combinations with rolling stock, and the cache is just like it goes one way, so up. So all right. Then before I go in, right, let's keep this a bit more interactive. We are a small group. It's a nice community. So how many of you here use relational databases for your core product, right? Not for things like Grafana or like third-party software, but for your product. Yep, cool. Yeah, just show of hands. Or if you have anything to add, you can always grab it. Yeah. And how many of you use NoSQL databases in some form? KV, Studios. Cool. So it's a very apt audience for this discussion, right? So I think I had some animations, but yeah, all right. Omio, before 2017, right? We were using, just give me a moment. I think, Omio before 2017, it was like around 2012 to 2017, right? We did have a very, painstakingly built and maintained multi-master MySQL, right? We were completely into RDBMS before Couchbase, right? We had a huge schema management process. We had a huge migration framework, thousands of migrations. We had like very critical processes to manage and orchestrate all of this, right? And it's like it's like Indians are kind of spiritual people, so it's like you have to do a blood sacrifice every time before you touch the RDBMS, and if you don't do the blood sacrifice, it's like you get punished when it finally runs, right? So it was like a lot of stuff that we were running as a team on blood, so fueled by a little bit of blood. Yeah, but we did it because if you're doing something, always need to do it proper. Yeah. Then in 2017, the team was like, we are having 200 plus engineers now. Everyone is asking for a database every week or at least once in a month. Hey, come on. We have a big storm. We have no more blood left to sacrifice. We're kind of running out of blood here. What do we do with this RDBMS situation? And you all know this kind of quote that there are like two hard problems. There are like many such binary problems. One of those is cache invalidation, right? So cache invalidation is hard, but when you have 3 or 4 data centers and you want to invalidate the cache across all of them at the same time, it's even harder because, well, if a ticket expired in Deutsche Bahn and got sold out, right? There is no point like expiring it in one data center and half your users are still seeing it in the other place. Yeah. And you all know like RDBMS partitioning, like table partitioning, manual sharding stuff. Yeah, it's hard. Doing that while having an active multi-master replication running. I wouldn't say multi-master though, like it's master-master. Technically, MySQL is not yet in a state where it can do multi-master. So it was hard with 2 as it was. Then relational database migrations are hard, definitely, right? But normalizations are even harder. Like for example, like a very simple example, right? We started with every user has a phone number, right? Now come and say, hey, you know what? Users can have 2 phone numbers. And it's like, ouch. Okay, so now you can technically put like, 2 phone numbers in one column, but it, yes, please. Yeah, no, you can go for it. Yes, it's like it doesn't pass first normal form. Like forget about 2NF, 3NF, BCNF stuff, right? Multi-valued columns don't pass 1NF, right? So now you need to have a separate table, phone numbers with the user ID, split this, add another migration, right? The thing is, if you don't have one NF, right, you cannot go and talk to an engineer credibly about database best practices. It's hard. Like, they'd say, hey, not doing one NF here. It's all contextual. Like, and then these exceptions keep growing and growing, and your schema is like slowly a mess because it's hard. Like normalization is one of these things where, like, you screw days away. Like you do it really well. Like you say, okay, we are doing 3NF or BCNF for everything. It still hurts. You don't do it, it also hurts. So, so yeah. All right, then infrastructure is hard. We all know like stateful infrastructure, even harder. Yeah. So we are facing this storm and we are like, okay, what are we gonna do now from here? There are a few strengths that we have, right? At that point as an organization is that we are really good at adopting tech decisions, right? We don't believe in just like selecting something and doing a prototype and leaving it there as a, like, we too do this, me too kind of like stuff, right? If we choose something, we're like roll out, roll out, roll out, program manage, finish it. Like take one choice, but like leverage it fully, squeeze it to 100%, right? And that's where we see the ROI, right? Launching is cool, rolling out is where the ROI is. Yeah, we some examples, but yeah, that's what we do every time. And we were clear on what we want and don't want, right? We have no more patience for like constant, these 3,000 migrations, 1NF, 2NF, BCNF, right? We had no more patience for it. We needed a flexible schema. Want to store 2 phone numbers? Come on, put an array, game over, yeah. So queries, we needed multi-region operational simplicity, right? You cannot like, yeah. Then we cannot allocate 1.5 terabytes of cache completely in RAM, right? That's a lot of RAM. But the thing is like typical cache servers, like at that point, Memcache, Redis, right? You need the whole data set in memory. It can persist to disk optionally, but the data set needs to fit in memory. There is no such thing as 2% in memory, 98% on disk, right? Yeah, we needed a flexible cache. And then it should not explode into even more technologies, right? Like we could have chosen some key value store, but usually this is how it goes, right? You choose a key value store, and then you need to do a bulk data migration or something, and now you need to use an ETL framework, right? Then and then you need to do some sort of like basic analytics, like how many people have a phone number, how many people don't. Now you need to do an ETL, load all of this into an analytical database, run some queries on the analytics database, and then from here take an update query, put it back there. So now one technology became 3 technologies and 4 technologies to manage. Yeah, we don't have the bandwidth for it. Like, yeah. So, yeah, definitely the slides are a little bit outdated. I had some. So from 2017 to 2022, we went from Couchbase 5 to Couchbase 6.6 today, partially in 7.1. Right? This is where we went. And even before this, we were using Couchbase for caching, just for like key value store. We are using Couchbase 2.x. Yeah. For those who don't know the history of Couchbase, it used to be like Couchbase, the word used to be CouchDB, Apache CouchDB plus Membase, right? Membase is the cache and CouchDB is the KV store. But Couchbase 5 is a document store. So it's like a version change, but a completely different product now. So this is an example of our, like before I go into the exact details, right? This is where we stand today, or like for the last 3 years, right? We have 2 data centers, completely independent of each other, right? There is like stateless cluster. Stateless means like only the applications like which have no volumes, no storage, nothing there, right? They run on all the data centers. There is the monitoring stuff, you can ignore it. Then there is Couchbase running on both sides. The only thing that is shared between the farms is data replication. That's it. The applications don't know about any other farm. They don't care whether they are running in the other farm or not. All they know is they can query the data here. They can query the data here. It will be the same data. Or they can look up the cache here. They can look up the cache there. It will be the same cache. This is all they know. They're like completely independent, right? What we really like from a document store, right? Especially from Couchbase, right? The first thing is there is global multi-master replication, as we saw before, right? You can launch any number of data centers in any number of countries, set up master between all of them in a circle, and they will all show you the same data, the same cache, right? And you don't need to have any code in applications that like, okay, if you're in Europe, contact the US farm for this. If you're in US, contact the European farm for this. No, you don't have anything in the applications about this, right? Second thing is we can bring down entire data centers, right? We want to upgrade Couchbase, fine. Take the whole traffic out to the other data center, update Couchbase, and bring the traffic back. Want to update Kubernetes, just shift the whole thing, update, bring the traffic back, right? We can do that only because the data will be consistent. We know that like when we are doing all of this, we are not like, losing data. Right? It's very important. Like without multi-regional data consistency, you really can't like, perform like complete downtime in a geography. The next thing, cache coherence across regions, right? Deutsche Bahn ticket sold out in one place, it's sold out everywhere. Done. Prices changed in one place, it's changed everywhere, right? It's as simple as that. And of course, like I had another point here is that cache can be also partially present in memory. So there is a resident ratio in Couchbase, right? So your data can be 10% in memory, but still 100% on disk, right? So it means that if you have a huge cache requirement, right, you can, just throw it at Couchbase, and you don't need to worry about like what is highly used, what is not so highly used, and so on, right? These are things that we really find a bit simpler, right? Then really simple operational model, right? All nodes are full stack nodes in Couchbase. Like everything is both master and coordinator, right? So that makes for a very simple topology. You can run 3 nodes and you have full quorum. You don't need to run 3 times 3 times 3, which is usually the case in some other NoSQL databases, right? Like for example, in some other databases, you need to run 3 just pure master nodes, 3 routers, and 3 data nodes. So 9 nodes for 1 quorum. And if you have like 2 or 3 regions, like, you have to scale in sets of 9. It's kind of tricky. Yeah, but in Couchbase, like, you can even have a single node in one data center. It's still a complete node, right? Then we have physically separate ephemeral and persistent clusters. Persistent clusters, we mean where documents never expire. There is no auto expiry key. Ephemeral means, yeah, worst case, we can lose the data because everything in the ephemeral must have an expiry key. The buckets come with a default expiry policy. Then, just give me a moment. I'll just come back for a second. I have the image here. Fancy boxes. All right. So then the next thing about the simple operations is that, okay, we have 2 production regions, full clusters, right? But we do a one-way replication to a single node instance. It's just one way, right? And because it's a single node, you can just take a full disk snapshot. You want backups, just schedule like Google Cloud or whatever cloud provider, just schedule a daily disk snapshot, and well, your backups are kind of solved, right? And all our engineers who want to test stuff, right? I want to check this query, I want to debug some document, I want to, like, we have dashboards, internal reports, dashboards, which do like super crazy queries all the time, right? You can point all the noise over here, right? And it'll never touch production, right? For an example, if you have a bulk update script, right? You want to do a huge select star update stuff. Just go ahead, do it here, right? Like stop the replication for 5 minutes, do it here, test it, fine. Turn on the replication, you got the production data back, right? So you can, you don't need to execute like the RDBMS slides. You don't need to execute a DB migration and pray to the gods or do a blood sacrifice anymore. Just like go do it. Yeah. Then on Kubernetes, right? Oops. Yeah, on Kubernetes. Not sure about OpenShift, but on Google Kubernetes engine, pod IPs are directly addressable, right? So if you are connected with your Office VPN and so on, pod IPs just work. Right. Mm. Yeah, got it. Cool. So here, when you're running Kubernetes pods, right, usually they have a overlay network, and those pod IPs are like virtual IPs. And here in GKE, the pod IPs are like real IPs. They're like any other VM. So you can just like ping the pod IP and it just works straight away, right? So we don't need to expose Couchbase with node ports, or you don't need a load balancer. Just hit the pod IP, as simple as that. So there is no intermediate routers or load balancers or node ports or port translation, port mapping, nothing is there, right? Then what we did was we have something called a DNS ingress, right? So you have the cluster, and then you have the Couchbase running on Kubernetes as a service, right? So we have a domain name for the cluster, and when you look up service dot namespace dot the cluster name. We made it so that from anywhere it goes straight to kubedns, right? So you get back straight the pod IPs, right? We don't, so it's like live resolution of pod IPs. You don't need to, like I've seen solutions where you have to take the pod IP and sync it with an external DNS. So every time your pod IPs change, you have to sync it with gcloud DNS or AWS Route 53. You have to copy paste the right pod IPs whenever they change. Nothing. So here you just have nothing. Just directly, so from anywhere outside, directly look up the service dot in any cluster, you get pod IPs, and then you directly talk to the pod IPs. There is nothing involved in the middle, no copying of records, no load balancing, no mapping. Yeah. What we found is that this is truly a game changer for any stateful set experience in Kubernetes. A lot for Couchbase, but generally for any stateful set running in Kubernetes, it's super useful, right? Then simpler document lifecycle, right? The documents are all independently versioned, right? In memory migrated. So when you load a document and then you save it back, you just migrate it back to version 2, right? Flexible data structures. So for us, like a migration means read the document and save it back. There is no like 2000 migrations, managed in some central repo. Just save a doc. I mean, get a doc, put it back, and it's like the new schema. Right? We use test containers for development. Of course, there is the defaults, right? Like Java, Spring Boot, Node.js support, right? So more or less, we have like lesser time spent on conforming to normal forms and stuff like that. More time just like go do what you want. So overall, at least in our situation, right, we use Couchbase as a document store and a cache server. I think if you looked at the previous presentations, it's capable of more, like there is full text search, there is a lot going on, right? But at least for us, right, this is already good enough. Like we are combining two technologies in one. It's already a good step. And it is globally replicated, right? You can launch databases, data centers, entire data centers, any part of the globe, and yeah, they are all connected. Very simple operational model, very simple engineering model, right? Lesser schema management, lesser normalization, stuff like that. Right. So the current state, right? Or when I say current, I mean like since 2019, all our databases are on Couchbase. Everything. As I said before, we are really good at adopting. So all of this, except right self-hosted stuff. Like if you are deploying a third-party server like Grafana, right? The thing that we see is that RDBMS, the only strong point today is that there is an ANSI standard for it, right? So when you're deploying, when you're offering some software for self-hosting or installing, right? As a software service provider, for you it is easier to just support RDBMS because for NoSQL, right? There is no proper abstraction for covering all the NoSQLs in the world. For RDBMS, there is. So if you're offering Grafana or anything else like a CMS, like a self-hosted CMS or any kind of open source software, it's easier for you to support RDBMS because of the abstractions, right? And because of the standards of ANSI SQL, like schema management, create table, square select, update, everything, right? So except for I wish personally there was some industry standard like ANSI, like the complete ANSI. I know that we know that Couchbase supports the nickel queries. It covers select update, but not the create table. Like, we still need to manage tables and structures, right? So I really wish there was an industry standard for KV and document stores. That would open up like even the self-hosted software to target any NoSQL database. Sadly, right, not right now. So we have few self-hosted, but then we bite the bullet. We are not doing multi-master for like Grafana or something. We are fine with a singleton instance. right? Stuff like Airtable, Grafana, we are okay with it, right? All the application databases on Couchbase. Then all the clusters are on the latest 6.6.x release. Right? Separate regions, separately tuned ephemeral persistent clusters, right? Full data and cache coherence. We have a very good understanding of day-to-day operations and reviews, right? So every week, there should be no query that runs more than 5 seconds. Take all the query logs, optimize. All queries must have limits in them. No primary indexes on prod. Every index should be replicated, should be partitioned, right? Resident ratio. So these are all like administrative processes that we have built because we adopt 100%, right? This is the ROI side, right? And this is possible only if we adopt technology completely. Yeah. Otherwise, for one or two buckets and one or two clusters, it's hard to find the economy of scale for this. 2023 and beyond, right? We are hoping to adopt Capella the same way that we adopted Couchbase. We are very hopeful, but it's done. It will be done when it's done. Yeah. We are on QA, but as you heard in the previous talks, like all our QA services are on Capella already. So now the only thing is going to production and comparing live. Like we can switch one region to Capella and one region to self-hosted and then do some A/B testing. I can't say anything. Like maybe if you come to the next meetup, like it's a sales pitch for the next meetup here. Hello. Yeah. So if you come there, we will present you some more findings on that. Yeah. Looking forward to seeing you everyone in 3 months. Yeah. So then all the QA services are already on 7.x because of Capella. And we hope that next year, everything will move to 7.x. We want to use collections and scopes. And we want to focus more on like programmatic, like when you have two regions, 50 buckets and 250 indexes, right? It's already a lot to manage. Like you have to maintain consistency. You cannot end up with like one index having replica and one index not having a replica. Like it's very easy to miss these things, right? We had a very nice talk before from Red Hat, right? About how this can be done with the operator, right? That's one way, right? And that is something that we really do. But our problem is that we are doing this since 2017, which at that point there was no operator possible. All right. So these are things that we really wish to extend. All right. I have a slide about common stuff, but I'll stop here for your questions before I try to preempt them. Okay? Thank you for listening. Any questions from? Yes.
Thank you. How are you managing your data warehouse? You mentioned one together with schemaless operational database. So if you just change the documents on read and write, and then what does the data warehouse say? Oh, I don't know what I'm getting now. How does it work?
Yeah. Is this, I can answer here. Is this about the data warehouse or the database?
About you mentioned the data warehouse at the very beginning, I think.
You mean this one? Like.
So started, you mentioned that you have a data warehouse.
Yes, we do have a data warehouse. Yes.
Yeah, and, I assume that your operation data flowing into the data warehouse.
Got it.
And how are you transferring the data from operation database
Good
to
point.
data warehouse if you are schemaless?
Yes. So this was an example to say like whenever we choose technologies, we adopt it to 100%. But we don't use Couchbase as a warehouse. We use it only for the live application database. Yeah, okay. And so your question is more like, what about the data warehouse? So the data warehouse for us is not getting data directly from the database. It is getting data through event schemas, which are all like, specifically entityed and versioned, right? And this is also like, so exactly to your question, the data warehouse gets data from the application directly, not from the database.
Kafka or whatever.
Exactly, yes, from Kafka and PubSub, right? But even within Couchbase, even within the live database, right, we do have a schema, right? But it's just that it doesn't need to confirm to 1NF or 2NF. So you can still have like arrays, and we still have like the object schema for it. If it's Java, there is a type schema. If it is TypeScript, there is a type schema. If it is JavaScript, well, then it's just like put something, get something back. Sorry about that. But so there is still a schema, except it's really flexible. So any other questions, please? Yep.
Normally it's considered to, I mean, if you use directly the pod IPs, this is considered a Kubernetes anti-pattern. And I think you have good reason to follow this approach. Could you please elaborate a little bit on this?
Yes, please. Yeah, pod native networking and pod IPs, right? Yeah. So I would say that, like, any stateful application, they do have discovery involved. Like if we are running it on plain VMs where the IPs never change, it's relatively easy to manage, right? But when we are running it on Kubernetes, right? Stuff like Couchbase or any stateful stuff, they have very application specific protocols, which cannot be properly load balanced, right? So if we put a TCP load balancer, it doesn't properly fulfill the Couchbase protocol, right? And the second thing is, when we started in 2017, Couchbase itself did not understand the concept of port mapping, right? The idea that you can have a node with separate private IP. It's like the node sees itself as 1.2.3.4 colon 11,000, right? But the outside world has to see it as 2345 colon 32,000, right? And when the bootstrapping happens, the SDK was not capable of understanding that there are two different ways to access the same cluster, right? This changed, I think, in the SDK around 2.7.16, which is not more than a year or year and a half old, right? Yeah, so we had to make sure that what the node sees as its own IP and its own port is exactly the same that the client sees as the IP and port. So we just maintain the same thing, and then we didn't need to map, like we didn't need to do port mapping or IP mapping, which made things simpler. We do the same thing for like Graphite, Carbon, like anywhere we want. And yeah.
Okay, interesting. Yeah. Thank you.
Any other questions? All right. All right. So common issues, right? We do have noisy neighbors, like when we have a cluster and there are like 10 buckets and 10 applications using it, right? Yeah, it's bound to happen. If one application is like trashing the cluster, the others get affected. That is why we have the no queries more than 5 seconds policies and things that are constantly reviewed and alerted. Right? Then the SDK itself, right? It got highly improved in version 3.x in terms of like memory management, thread management, everything, reactivity. Like I think the SDK was a complete rewrite. So if you're already using Couchbase, and if you are by chance on the 2.x SDK, I would highly recommend like just upgrade to 3.x. It's It's not a lot of, you don't need to change the code. You just need to change the way the connection happens, just the bootstrapping, right? Otherwise, it's vastly better than the 2.x SDK. Then XDCR, when we were in Couchbase 5.x, right? You have two clusters, and if one cluster is slow, the XDCR backlog will keep growing in the other cluster, and the other cluster would also become slow, right? This was again vastly improved in 6. Like I've not seen this issue in the last 3 years, right? And yeah, for sure we had clusters shut down and opened up all the time, right? This was like, so now we can have clusters out for like 1 day, no problem. The XDCR queue will keep increasing, but it doesn't affect performance in any way of the other clusters, right? The known limitations, right? Yeah, there is document limits, like just like any other database, like, yeah, there are document limits, there are bucket limits. Yeah, fine. Then there is like the roles, right? If you grant an application access, right? It automatically gives the application privileges to create indexes. And when a live database is running and you create an index, right? It's going to scan the entire bucket to initialize that index. We don't recommend creating indexes when there is live traffic running, right? We always switch the traffic over, create the index, switch at this side, create the index on the other side, right? But sometimes applications just check in code, or Spring Boot behaves in weird ways. Like you put @index, some magic annotation, and it tries to create an index, right? It needs to be a bit careful, right? And then the other common thing that we see is that engineers need to be onboarded about document stores, right? They still believe, like for those coming from an RDBMS background, it's a little tricky. We should onboard them. And for those coming from a key value background, they think, oh, what is this? It's just a get put store. No, it's not get put. It's a document store. You cannot throw in blobs in there. If you want to use it the best way, right? For example, we've seen cases where to bypass the 20 MB limit, right? We try to compress the data, gzip the data and store it. But now you lose all the indexes. It's gone. Like, and then people ask, oh, why is my query not working anymore? Of course, it won't work. So yeah, it's important to, like, not all NoSQL databases are created equal, right? And it's very important that engineers understand what they are working on. Some things I don't know which bucket to put in, right? Foreign key constraints, it is well known, it's not there in NoSQL. Pick any NoSQL, right? Cloud native NoSQL, it's not there, right? It's just the new normal, right? And I don't know what to make of it. Right? Your answer is as good as mine. So then, of course, as we said, there is no client standard or ANSI standard for, forget about NoSQL, that's a big term, at least for KV or at least for a document store. Yeah, it impacts wide adoption of NoSQL, because not everyone can support every single NoSQL vendor in their clients and in their servers, right? So to that extent, this is still a vendor-driven world, and I hope it becomes a more standards-driven world. All right, that's about it from my side. Thank you.
Thank you, Subhas. Thank you, Jose. I mean, we can't thank you enough for having out so much. And again, thanks everyone for having organized this, Rainer, Sebastian, Carsten, Juliana, and everyone that was involved in this event. So I just wanted to give a couple of communications. So we finished the talk, so you can, have a little bit more time to exchange some ideas and discuss with your peers. We've got food there, drinks, so we're going to stay here in the next hour. One important thing my colleague Sebastian is asking is he's going to send you, if he hasn't sent yet, a link to a post for this event with a couple of pictures, a few pictures for this event. So we would really appreciate if you enjoyed this event and if you would like us to continue running this event, which is actually what Subhas and we were planning, obviously it would be very useful to have a little bit more traction to this event. So if you can share that with, or anyway, just like it, I think it would be very helpful for us to keep running those events. So that's the second thing. Third thing, I think there was something else. Oh yeah, so after this event, as mentioned at the beginning, we are going to be flat for this jam session. It's going to be around 8:30, 9 o'clock. The drinks are going to be on Sebastian, so that's fine. And yeah, if you would like to join us, you're more than welcome. Thank you.